Hello students, today in electrostatics we are going to discuss a concept of electric field. It is one of the most important concept in the total electrostatics. There are a lot of concepts are involved in this. So basic is very simple, you can understand. First, what is electric field concept? It is one of the practically saying, it is one of the imaginary concept, practically not existing concept, but using this concept what we can explain is we can able to explain the interaction between the charges, because you know that according to Coulomb's inverse square law, whenever the two charges are taken, that is plus q and minus q, if we taken plus and minus, both will attract each other. If we taken the two similar charges plus and plus, both will repulse each other. So here the interaction between the two charges, whatever we are explaining, that strength, what strength it is attracting, what strength it is repulsing, that we can explain using a imaginary concept called as electric field concept. Okay, this electric field concept, before doing that, okay, this strength, whatever the force of attraction and repulsion, we are explaining in two ways. In the two ways, first one is called as electric field intensity concept, we are indicating with the letter E. This is one of the expression of the strength of the force of attraction or repulsion in terms of vector quantity, that is electric field intensity concept. Second one is electric potential concept, the same strength between the two charges either attracting or repulsing, that is electrostatic force from the two charges, we can explain it in terms of the potential concept, that is one of the scalar concept, that is called as potential. So we are going to discuss only now the electric field concept. What is the electric field concept actually? So come across the case of one charge. This is called as source charge, okay, which produces the, that means which gives the certain strength. Now what we are doing is we taken one charge near to this called as test charge. Whenever you taken the test charge always we are taking as a positive charge. So whenever you take kept the one of the test charge near to this charge, then what happens according to the Coulomb's inverse square law, they are going to be repulse each other. When they are repulsing each other, then what happens, how much strength it is repulsing, that depends on the magnitude of the both the charges, and you know that it is inversely the square of the distance between them. Now if you taken this test charge here, the force acting on this test charge is one value. If you are taking the test charge here, the force acting on this one is another value, like it, right? So different places the force acting on the test charge will be different. If you say points are A, I am taking second point is B, and third point if I am saying is C, the force acting on the charge at A, B, C are not same, that is different. You can understand by, okay, basic formula. At A point, the charge is near, so force will be more. B point, charge is a little bit more distance, so force will be less. C point, less distance, so less force. So here the parameter is the force acting on the charge is different. So this source charge influencing the other charge at A point, B point, C point, yes or no? Different values, different values. So at A point is more, B point is less, C point is much less. So like that, if you taken up to what distance, that means if you are keeping the source charge around the, okay, if you are keeping the test charge around the source charge at a distance where the force is not going to be acting on this one, that is force equal to 0, right? Up to that, I can say that up to that, that means within that, up to that, what happens, this charge will be influencing on this charge, I can say. So the concept of electric field, we can say simply, it is the region up to where the influence of the one charge is felt on the other charge. That means this charge is influencing this charge up to this, where the force is acting 0. Practically, you can say that is at infinity, because whenever you take any test charge, source charge, if you keeping the test charge near to this, if you keep this test charge at infinite, then the force acting on this one becomes 0. Like that we are taking. Okay. So here, what is the statement of this electric field means? The Q, source charge influencing the test charge. Up to what region? Up to here. This is the region up to where it is going to influence the test charge. Up to what region the source charge is influencing the test charge, that up to that region is called as electric field region, we are calling. That electric field region strength we are calculating in terms of electric field intensity concept. Okay, so here we are defining like this. Electric field intensity, okay, due to a source charge at a point, that means electric field intensity due to a source charge, okay, source at a point. Suppose if we take an at a point, what is electric field intensity at a point? That we can calculate, that is like this: force acting per unit test charge at that point. That means force on the test charge at that point, how much, that much electric field intensity is there at that point. We can say, if you want to calculate at B point, what is the force acting on that test charge at B point, that we are calling as electric field intensity at B point, and how much force is acting on the same test charge at C point, that is we are calling as, okay, electric field intensity at C point. Now if you observe this one, already we know that A point force is more, so electric field intensity at A is more, we can say, compared to B, and B electric field intensity more compared to C, because already you got it, force on the test charge at A point is more than B, B point is more than C. So electric field intensity simply we can come across as a definition statement. The force acting per unit test charge is called as electric field intensity. More the force on the test charge at that point, more the intensity, less the force at that point, less the intensity. So this electric field intensity is a vector quantity. We are measuring in terms of, as per the formula, F by Q naught. Test charge based we are explaining. So force we are measuring in terms of Newton, and the charge we are measuring in terms of Coulomb. So this we can write as Newton per Coulomb or Newton Coulomb minus 1. This is the electric field intensity units. So this is the way you are going to define the, okay, electric field intensity. So I can write the electric field intensity statement. Now statement of the electric field intensity. Electric field intensity can be defined as, it is the force acting on test charge at that point of distance is called as electric field intensity. The units of this one is Newton per Coulomb. Formula we can write as E is equal to force acting per unit test charge. So here force is a vector quantity, electric field also a vector quantity. This is the way you can write. Okay. Now expression for the electric field intensity. Electric field intensity is vector quantity. We are first writing the magnitude of the magnitude form of equation. So here I taken one source charge plus Q, and I taken one test charge here. That means, okay, at a point P, I am finding the electric field intensity due to the source charge. So at this point, to find the electric field intensity, if there is a charge, you can take it. If there is no charge, you have to imagine a test charge at that point, that is called as Q naught. I taken Q naught here. The distance of the Q naught from the source charge is how much? R. Now what is the electric field intensity at that point? The electric field intensity at that point P. Okay, in terms of magnitude based we will discuss later, we will convert into, okay, vector form. So electric field intensity at that point, as per the statement, force acting per unit test charge. So at that point, how much force is acting on the test charge, that much electric field intensity is there, that we can define. Now what is this F here? F is called as force between the two charges, because this capital Q, the source charge, this is test charge, both are repulsing each other, okay, opposite direction according to Coulomb's inverse square law. As you are looking like this, along the line joining between these two charges, the force of repulsion takes place. So what is the F formula here? The force is equal to, we can write 1 by 4 pi epsilon naught according to previous classes. One charge is capital Q, second charge is test charge, Q1, Q2 by, that means capital Q, Q naught by distance between them. Which distance? Square of the distance between them, that is R square. Now this formula to take. Now substitute that form like this above equation, that is EP is equal to 1 by Q naught if you take in common here. Then I can write this one as 1 by 4 pi epsilon naught into capital Q small q naught by R square. There are many different methods to solve this. Just we are taking one of the method. Q naught get cancelled. So electric field intensity at that point is equal to, I can write as 1 by 4 pi epsilon naught, that is Q by R square is the formula. So if you observe this formula, in this case we have only one charge is we are getting, that is source charge. That means we are calculating the electric field intensity at a point P due to this source charge. That's why electric field intensity formula also you will get only one charge, that is source charge. Due to this charge only we are getting this electric field intensity at that point. That point, what distance it is? R distance. More the distance, okay, less the electric field, less the distance, more the electric field. So I can write simply electric field intensity at a point is inversely to the square of the distance it follows. It is most important to understand here. So basing on this one, what is 1 by 4 pi epsilon naught anyway constant? You know that is 9 into 10 power 9. Same like Coulomb's inverse square law relations we can follow to solve the certain problems here. Now if you want to write this one in the form of, okay, electric field, that means the form of vector. So electric field is a vector quantity, that is we can write as mod E into, that is position vector, that is nothing but R cap. R is a position vector if you take in. So what is E? Just we got it at that point P, that is nothing but 1 by 4 pi epsilon naught. I can write as capital Q, okay, by, okay, R square is a formula into R cap, nothing but I can write as R by mod R. According to unit vector can be written as vector by magnitude of the vector. So I can write here. So simple form of electric field intensity in terms of vector form is equal to 1 by 4 pi epsilon naught, that is q by r cube by convert, because this is r square, this is r cube into along the direction of vector r, position vector r. So this is the expression for electric field intensity at any point in terms of position vector of that one. So main point is electric field is one of the imaginary concept. So how much force is acting on a test charge around the source charge, that much electric field intensity is there at that point, you can say. Suppose if the test charge is experiencing more force, more electric field, less force, less electric field. Suppose if there is no charges given, except the source charge, in that case you have to imagine a test charge surround the source charge at any point. Now how much force is acting on that one, that is you have to take as electric field intensity at that point. What is electric line of force? Electric line of force is one of the imaginary concept of understanding the strength of the field without going into the complicated condition. Higher level, some problems can be done using electric line of force concept. Here simply, so I taken here one source charge Q. Due to this, around the source charge, we have a electric field intensity. At any point, if you want to calculate, at this point, if you want to calculate the electric field intensity, how much force is acting on this test charge, that much electric field intensity is there, I can say, as electric field intensity like this. Already we defined. But what is electric line of force? Electric line of force is the concept of force along which the test charge is going to be experiencing the force. If you see in this case, plus Q, source charge repulsing this test charge at this point, force, how much force is there, that much intensity is there, we can say. But according to the direction of the repulsion, this test charge, source charge repulsing this one in this direction, yes or no? So when it is repulsing, what happens, this test charge Q naught will move in the direction of the arrow. So along which line the test charge is moving, that path is called as electric line of force, the line of force. This is called line of force. Where this line is going to end, where this line is going to end. If you continue this one, actually this line is going to be ended at infinite. So this is the way you can take, it is going to be ends at infinite. That means the electric line of force start from the charge, ends at infinite. That means in this case, if you come across a case of positive charge, the positive test charge will be repelled, so electric line of force will be away from the positive charge. Suppose if you taken in the case of negative charge, in the case of negative charge, if you taken, this is one of the negative charge I taken. In this case, what is the direction of the electric line of force? If you taken a test charge, if you taken a test charge, this is the Q naught test charge I taken. Now this test charge will be moved in the which direction it is going to be attracted. This is a negative. Test charge is always positive, so it is going to be attracted. That's why what happened, this is the direction of the test charge motion. So electric line of force will be towards the test charge. But where it is start from, if you taken the test charge at infinity, the electric line of force also I can take it from the infinity. Electric line of force also I can take it at infinity. So from infinity, this electric line of forces are going to act like this. So the main point you have to understand, electric line of force start from positive, ends at infinite. And for the case of negative, starts at infinite, starts at infinite, but ends at charge. That means due to attraction, it is start. Electric line of force starts at infinite, ends at minus Q. So due to attraction, these are the two types of electric lines we can say according to this one. The one is called as line which is electric line of force which is going away from the charge, and another one is the electric line of force which is towards the charge. If it is going away from the charge is we are taking as plus Q. If it is towards the charge, that is we are taking as minus Q. So according to the line of charge, we can say here positive charge, electric line of force away, negative charge, electric line of force towards. So using the electric line of force, we can able to explain the strength of the electric field intensity. The electric lines may be a straight lines as you are looking like this. The electric lines may be curved lines. Next, if the electric lines are crowded, then we can say electric field intensity more. If the electric lines are spreaded, electric field intensity less. If you see this example here, second one, this is the curved lines. Here the electric lines are crowded. Here the electric lines are spreaded, little bit gap is there. So here electric field intensity, I am taking the 2 points here, A point and B point. So electric field intensity at A point is greater than electric field intensity at B point according to the number of lines which are spreaded. More the number of lines are there in a small region, more the electric field intensity, less the lines, less the electric field intensity. If you see in this case, I am taking the two lines here, that is A point, 3 points, 2 points A point, B point. Anywhere the number of electric lines are same, so electric field intensity in this case will be same at any point. So whenever the electric field intensity at any point is same, that is called uniform electric field. Whenever the electric lines are electric field intensity due to electric lines are different at the different point, then that is called as non-uniform electric field. So this is one of the non-uniform electric field. This is one of the uniform electric field of lines. So electric lines of force, by looking at it, you can say that more electric field, less electric field concept here. Now we are going to discuss about the electric line of electric lines and the concepts of that properties of that electric lines. We will discuss in a short way. Properties of electric lines of force. First one, the electric line starts from positive and set negative. That means I taken one of the positive charge here plus Q and I taken minus Q here. This electric line of forces always starts from positive and it is going to be end set negative. This is the first property of the electric line of force. In the case of positive charge, electric lines will be start from positive and end set infinite. In the case of negative charge, the electric line of force starts at infinite and ends at negative charge. This is the first property, start from positive, ends at negative. Second property, more the number of electric lines of forces, more the electric intensity at that point, less the number of electric lines in the region, less the electric field intensity at that point. I taken here one of the electric lines of forces, group of electric lines are taken in this case, A point outside, B point inside, C point also inside. The electric field intensity at A point, there is no lines of forces are passing here, that's why it is 0. Now if you see this one, what is the electric field intensity? There is some number of electrons, electric lines are passing at B point, so there is electric field intensity at B point. And if you see that there is electric field intensity at C point also. But if you see that the distance between the two lines, at the point of B is very near, at the point of C is very far. So there is no electric lines at all at A. So I can say simply electric field intensity at B point is more than C point and C point is more than A point. So this is a way you can write the relation between electric field intensity at different points of the electric field using second property. More the number of lines, more the electric intensity, less the number of lines, less the intensity. Next point, no two electric lines of forces intersect each other. Means what? There is a lot of number of electric lines will be present around the charges. So no two electric lines will be cross each other as a looking like this. That means at this B point, two electric lines are crossing each other. That is, you can say E1, E2. So in this case, is it possible that two electric lines will cross each other? Means no. According to electrostatics or electric lines of force concept, no two electric lines intersect each other. If they are intersecting, actually, what is happens due to a one charge, if you are getting the number of lines, if they are intersect each other, at that point, it must have a two directions of the electric field. At a single point, this is a single point P. At this point, two electric fields cannot be possible by a single charge. So at a point, two different electric lines is not possible. That is according to geometry. We can go for next property, that is according to the tangent. So here, if you take the geometry, the tangent I can draw here, I can draw another tangent here. So at single point, geometrically, two tangents are not possible. That's why no two electric lines of forces intersect each other. If you say it is intersect each other, it is compulsory that they must have two different a tangent. It is not possible for a single point having two tangents at a time. Next property is tangent gives the direction of the electric field at that point. Means I taken one of the electric line of force. They are started from the source of charge like this. Now our point is at this point. At this point, what is the direction of the electric field? At this point, what is the direction of the electric field? That is I am taking as B point. And at this point, what is the direction of the electric field? So if you want to calculate the direction of the electric field at any point, take the geometrical tangent line. This tangent gives the direction of the electric field at that point. So that means I can say simply this gives the direction of the electric field at that point. Just a minute. This direction gives the direction of the electric field at this point, that is EA. Now, what is the direction of the electric field at this point? At this point, you take a tangent, okay, that gives the direction of the electric field at this point. This is the direction of the electric field at this point that we can write as EB. Similarly, what is the electric field direction at this point? Here also you draw a tangent. Tangent nothing but geometrically a straight line that gives the direction of the electric field at this point. This gives the direction of the electric field at that point. So I can say electric field intensity indicated for any type of electric line of forces in terms of tangent taking that. Suppose if you take an electric line as a straight line, in these cases at this point, what is the electric field direction at this point? You take the tangent, that is only the direction of the tangent, that is only straight line. So that means I can say here this is only the tangent line, that is only the direction of the electric line of force, we can say. This is only the direction of the electric field at this point. So the tangent drawn at any point gives the direction of the electric field. This is another property. Next one, electric lines of forces never forms a closed loop. That means like magnetic field starts from north pole and south, okay, it goes to south pole, again inside south pole to north pole, like that it forms a closed loop. But in the case of electrostatic, electric field never forms a closed loop. So look at here, it is starting from positive. I taken two charges here, positive and negative. If you say positive, start from positive, and this electric line is going to be end set negative. And here also starts from positive, ends at negative. And some other lines are given here, three lines here, they are coming from infinite to the charge minus q, and three lines from the positive charge to ending at infinite. Ending at infinite, it is not, okay, that means, so electric lines of forces never forms a closed loop continuously, it won't form, it starts from one charge and it ends at another place. So that is one of the most important property at all. Next property, near the charge, electric lines are crowded. Okay, near the charge, electric lines are crowded means if you see this one, this is the charge, positive charge. Near this one, at this region, all the lines are very near. So near the charge, lines are forces are crowded and they are spreaded. Where far? Far they are spreaded. Far they are spreaded means far means if you see this one from the if you are going away. Okay, this is the place. If you go away, the lines of forces are going to be spreaded. That is called as concept of near the charge, electric lines are crowded, and away from the charge, electric lines are going to be spreaded. That we can say in another term also here, longitudinally crowded and laterally spreaded. Longitudinally means what? Along the length. This is the direction. If you say this is the direction where it is crowded, and this is the direction they are spreaded. So this is called lateral direction. Okay, this is called lateral direction. This is called longitudinal direction. So along the longitudinal direction, the electric lines of forces are crowded, and along the lateral direction, the electric lines of forces are spreaded. This is also one of the property we can say here. And in this case, these electric lines of forces are going to, okay, comes from the charge. Suppose if we taken a charge, that is one of the single charge I taken here, spherical charge body, if you say, how these charges, how these electric lines are going to come from this charger body. The electric lines of forces will comes from this charger body. As you're looking like this, it comes like this. The electric lines of forces will be comes like this. So in this case, I can say here how much angle it makes. It makes an angle 90. That is called as normally. The electric lines of forces originating from the charger body always normally like this. Electric lines of forces always originating normally from the surface. Charger body, from the charger body, it is always originated normally. This is important point to understand here. This is also one of the property we can say as a sixth point in this. Now go to the next point. Next important point, electric lines of forces do not pass through the conductor, and electric field inside the conductor is zero. Means I taken one of the conductor, conducting sphere, and that is kept in the electric field. Whenever it is kept in the electric field of intensity E, Now this is the way the lines of forces will appear. That means the electric field intensity inside will be 0. That means we are not finding any electric field inside, because in the case of conductor, the number of positive charges, how many is there, the electrons also will be same. So due to that, what happens, it acts like a neutral body. That's why the electric field intensity will be 0. Now, but in the case of non-conducting, this is in the case of conductors. In the case of non-conductors, in the case of non-conductors, if you see this one, the electric lines of forces reaches to the surface of the sphere, and again it passes inside, because non-conductor contains the, does not contain the free electrons inside. That's why what happens here is the positive and negative charges will be spreaded throughout the surface of the conductor as positive one side, negative one side, which creates the electric field inside as the induced electric field we are calling. This is the actual electric field, and inside the conductor there is electric field exists, that is called induced electric field. Due to that, I can say that electric lines are going to passes through the non-conducting materials. So electric lines does not passes through conductors and passes through non-conductor. This is also most important point of properties of the electric line of forces. These are the most important electric line of forces properties. Now we'll go for some diagram based how the charges electric line of forces looks for the combination of certain charges, and graphs we will discuss. Now we will discuss some patterns of electric lines, how this pattern will be there for different charger bodies. We'll discuss now. Now come to the case of first one is only positively charged. That is isolated positive charge if we taken only positive. How these electric lines will be drawn? Due to this positive charge, it is a spherical body, positively charged if you like, if you taken. In this case, this is the way the electric lines are going to be taken here, because according to property of electric line of forces, electric lines will be always passes normal to the surface. So I can take the diagram of this one, electric line of forces, from any point I can take it like this, normally like this. We can take many number of lines as much as you can. So this is the way the electric lines of forces start from positive and set infinite. So this is a diagram for which one? In the case of positive charge. That is in the case of negative charge, how the electric lines of forces, in the case of negative charge, the electric lines of forces will be start from infinite and set negative, start from infinite and set negative. Like this, the electric lines of forces will be originate at one position and set another position. This is the way you can see the diagram for the negative charge, electric lines of forces in the case of negative charge. Now if you can make across a case of positive and negative, one charge is positive, one charge is negative, already we discussed here. From here, this is the way the electric lines of forces will be start from positive and set infinite. Some lines, right? Here also in the case of negative, some lines comes from the infinite and set negative, and like this, as they're looking like this. 3 lines I am taking here for understand. But in between, what is happening? Plus minus is there. So here the electric lines of forces will be due to force of attraction. They are going to be the line of force which is start from positive, that will be attracted by the negative. The line of force which is start from the positive, that will be attracted by the negative. So this is a way you can say the electric line of force start from positive and set negative. One line I have taken here, and here one more line I am taking here. So electric line of forces start from positive and end set negative, as I am looking here. So in the case of plus and minus, some lines will be away, some lines will be towards the negative charges like this. Suppose in the case of 2 positive charges if you taken, what way the electric line of forces will be there? In the case of 2 charges, first near to that, if you come across a near, so these electric lines and these electric both are repulse each other. That means the electric line of forces will be repulsed like this. The electric line of forces will be repulsed as they're looking like this. So in this case also, the electric line of forces, whatever it is you are seeing, that electric line of forces will be repulse each other as they're looking like this. So these electric lines of forces which are repulsing each other, that will be strength will be different at different points according to our discussion. These electric lines of forces are going to repulse each other. This is the way the electric lines of forces are going to be repulse each other. Then what about this electric lines of forces which are away here? This will be in the form of straight lines. It will go start from positive and set negative. This is the way the electric lines of forces will be originate from the positive and set negative. Here also originate from the positive and set infinite. Originate from the positive and set infinite. This is the way the electric lines will be there. So if you observe this diagram, in this case, the electric lines of forces are looking little bit different here. So what way? So if you observe this one, these plus and minus. In the case of this one, plus and minus, we have a region of electric field bounded here. But in the case of this region, plus and plus, there is a no electric lines are present in this region. So this is the region we are calling as null region, where the electric field intensity is equal to 0. Electric field intensity is 0. That means there is no electric lines of forces are present. That's why that region is called as null point region we are calling, or neutral point region also we are calling, where the electric field intensity is equal to 0. So this is the most important point. So identifying the null. Next, if you come across the case of example of this one more addition point I am taking here. This body having contains one more line. So here what I am doing is I am writing the charge on this one is equal to Q1, the charge on this one is equal to Q2. So they will ask the question, which is having more magnitude? Two positive charges kept side by side. Using the line of forces, you can able to explain which magnitude of the charge is more, which magnitude of the charge is less. If you see this one, in this case, to explain this one, I can say Q1 is greater than Q2. That means the magnitude of the charge Q1 is more than Q2. How we can say this? Just count the number of lines here: 1, 2, 3, 4, 5, 6, 7, 8, like that. So more the number of lines, more the magnitude; less the number of lines, less the magnitude. So the first contains more number of lines, the second contains less number of lines. So I can say Q1 is greater than Q2. So this line of force concept explains the strength of the field also. More the number of lines, more the electric field; less the number of lines, less the electric field. So like that, you can able to explain the concept of this one. Now, just before we discussed about uniform electric field, non-uniform electric field, right? So here also we can have examples of this one. I taken two capacitor plates. It will come in the current electricity. And you've taken the two capacitor plates. One is positive plate, one is negative plate. In this case, there is electric field exists between these two plates, as are looking like this. So electric lines of forces start from the positive and set negative. So these the lines which are started from positive and set negative. They start from positive and set negative, as they are looking like this. These are the electric lines of forces which are start from positive and set negative. So we can take many number of lines which are starting from positive and set negative. These all electric lines which are looking, they are uniformly spreaded electric lines, because equidistance between them. That's what is called uniform electric field. Now if you come across the case of this one, this is one of the positive sphere, if you say, kept near to these plates, then what happens? How the electric lines? These electric lines will be start from the positive body and end set negative plate, like this, as you're looking here. But all the cases, one or two lines may be like this, but remaining lines will be not a straight lines. The most of the lines will be curved lines. You can see this is a way you can see the curved lines start from positive and set negative, as are looking like this. And these are the lines of forces, I can say. It start from positive and set negative. So we can write the electric lines of forces like this. So I am taking only few lines. So in this case, this is one of the non-uniform electric field example. This is one of the uniform electric field examples. So according to the type of charged bodies we have, either it may be uniform electric field or non-uniform electric field. Next, we are going to discuss about electric field due to different charged bodies. This is most important here. Mathematical approach is going to be, we are going to discuss now. Electric field due to different charged bodies. We have different shapes of bodies according to the distribution of the mass. According to the distribution of the mass, different types of charged bodies also we have. Previous class we discussed, like linear charged bodies, aerial charged bodies, volume charged bodies. So on that we have different charged bodies, and we are finding electric field intensity due to the charged bodies using mathematical approach for the mains and advanced level, some derivations and some important concept based, formula based okay, problems also we can able to understand in this topic. What are the things we are going to cover in this? First, we are going to discuss about the charger wire. That means we taken one of the wire which is where the charge particles are distributed linearly. So that means linear charge density related, okay, electric field intensity charger body. So charger wire we are taking. There are two types of infinite length one, finite length one. Okay, we are going to find. Next one, charger ring. That means we are taking one of the ring. Okay, if we are charging that ring, what is electric field intensity due to the charger ring at any point around that charger ring, inside or outside, whatever it is that we are going to discuss. There are different types of rings we can take: full size ring, half ring, and quarter ring. Like that, we can able to discuss. This is important for the competitive examination for the mains and advanced levels. Next one, charged disk. So whenever you take in the charge disk, the particles are distributed area wise, the charges also distributed area wise. So basing on the areal charge distribution, we can discuss the electric field intensity due to charge disk here. Last one, sphere we can discuss, and the sphere, in that there are two spheres are there: solid sphere, hollow sphere is there. And whatever it is, solid or hollow, okay, hollow sphere having only surface area, not having volume. So solid sphere having volume. So according to volume charge distribution, you can able to explain the electric field intensity due to this charge space in this. Here also there are two conditions we are going to discuss. Most important, that is conducting sphere, non-conducting sphere. Because just before we discussed that electric lines of forces will not passes through the conductor, will passes through the, okay, insulator. Insulator means non-conductor called as insulator. So based on that one, we have different conceptual applications are there. You need to understand the derivations and equation part of that. Now we are going to discuss about each one. After this, we will go for the next topic. Now come to the first application, finding of electric field due to charger wire. Electric field due to charger wire. I taken one of the wire. You can see negligible thickness. That means it is having lengthy wire of infinite length. So this is infinity. This is also infinite length wire, which is having charges. That means we given the charges onto this one, you take the charges as positive charges like this on this. It is one of the charger wire of length L. The total length of the wire you can take it as L. The total length of the wire is L, that is infinite length of wire L. So now we need to find the electric field intensity due to this charger wire at anywhere. So first point, I am taking 2 points here. One point I am taking on the line here. Second point I am taking here. So to understand the electric field intensity, always keep it in mind. Already we discussed electric field intensity inside the conductor is 0. So if you see the first point, the point is located along the conductor. That means the electric field intensity at this point equal to 0. But if you come across the case of this point, this is the point not inside the conductor, it is outside. So what is electric field intensity? Electric field intensity start from the, okay, charger body normally, and it reaches to the point, okay, in a straight line, right? And in this case, to understand the direction of the electric lines of forces, you have to imagine a test charge at that point. What point you want to calculate the electric field intensity direction? So first I chosen the point of distance I chosen as x here. X is the distance of that point. Now to find the electric field intensity at that point, first, this is infinite length of conductor. We have many, okay, number of charges will be there. So for that, you choose a small elementary portion of this conductor. This elementary portion of this conductor I am calling as length dl. Total length of the wire is I taken as capital L. The small length which I chosen is called as dl. Now due to this dl, it contains the charges, and here there is a test charge we imagine, that is also positive. The positive repels. That's why what happens, there is a repulsion force takes place. What direction the repulsion is there, that is the direction of the electric field at that point. So due to this, okay, elementary portion, what I can say here, there is a electric field intensity at this point in this direction. So I can say that this is the direction of the electric field due to this charge. That is nothing but I can write as electric field intensity direction. This is at this point. To understand the concept here, we need to understand some geometrical terms here. In this case, this elementary portion which you chosen, it makes certain angle here. That angle I am taking as theta here. Clear? Next, also this elementary portion which is chosen, that can be chosen from anywhere. Now here, this is the line I chosen the point. called as line of bisector, you say as O. So from the O, this, okay, length of this conductor you take it as some like L, small l. The total length of the wire is L if you say the L, that means the distance of that elementary portion I chosen from the, okay, line of bisector is, you take it as L. Now the point is a distance of X, the elementary portion I chosen at a distance of L. From, okay, due to that elementary portion charge, there is electric field in this direction as you are looking here. So to understand the concept, to solve it here, first at this point, imagine, okay, yes, at this point you take the, okay, just coordinate system. To understand here, I am taking the coordinate system here, one, that is y-axis, second one is I am taking x-axis here to solve the problem, because electric field is a vector quantity. That electric field vector quantity is not along the x-axis, this is x-axis, not along y-axis, it is making some angle here. So according to that one, using the component methods and using some integration methods, we can calculate the electric field intensity at that point, because it is not a single charge, it is infinite length charge wire. So each charge will contribute the electric field at that point. So to calculate the electric field by the total charged wire, it is very difficult. For that we are using the integration method to solve. For that I am choosing the small elementary portion. Due to this I am finding the electric field intensity here. That electric field intensity, using the integration, I can calculate for completely, okay, infinite length wire. So for that, first the terms are most important here. So here from elementary portion to this point, what is the distance? The distance you take as R. R is the distance of the point from the elementary portion. That means the elementary portion contains the charge. How much charge it contains? That charge you take as dq. The total charge of the wire is, you take it as capital Q, because it is a charged wire. Total length of the wire you take it as capital L. The charge, okay, elementary portion which chosen, the charge on that one is equal to dq. This dq repel this q naught in this direction as electric field intensity E. That is due to which charge? That is positive charge anyway, right? So now according to geometry, how much angle it is making, here also I can take it as theta here. So I can resolve this E into components, like two components I can write. One is, according to this one, I can write as X component I can write. Second one is I can write as Y component I can write. Just I am giving the concept here. So that electric field at that point P, this is the point P I am chosen here. The electric field at that point P is equal to, I can write electric field at that point P is equal to what I can write, that is electric field due to x-axis plus electric field due to y-axis. This is both you have to take. Now what is electric field along x-axis? First you have to calculate. What is electric field along y-axis? You have to calculate like that. Now in this case, to proceeding into this, so first formula based will go, then after we'll go for, okay, derivation of this one. Now if you write the formulas for Ex, what is Ex formula? Ex is nothing but I can write as E cos theta, because it is making an angle theta with x-axis, E cos theta. Similarly, Ey is equal to E sin theta. This is one, two components. Next, what is E here? E is called electric field intensity. So electric field intensity formula is nothing but 1 by 4 pi epsilon naught. Yes or no? According to the formula, Q by R square is the formula. What is Q charge? Here, what is the charge we chosen here? Elementary charge, that is dq by distance, square of the distance. What is the distance between the elementary portion to the point? That is R is the distance here. So R square. So if you observe this, okay, E along x-axis, if you want to calculate, the formula will becomes E cos theta will become, so 1 by 4 pi epsilon naught dq by R square into cos theta it becomes. So to find the Ex value, what is dq? Dq is constant or variable? Variable. From where to where? From infinite to infinite, because if you taken a small length, dq's value is different. If you taken a big length, dq value is more. So charge will be depends on the size of that length of that elementary portion which you choose. So dq value is variable. So which is variable? I am keeping in red mark. Which are variable? dq is variable. We have to modify. 1 by 4 pi epsilon naught is constant. If not, is not a variable. What is R? Distance. Now look at this one. This is the elementary portion. This is the distance R. Now this length, whatever this length is going to be changes when you choose the elementary portion at different points. Suppose this elementary portion, if I choose in here, what happens to that length? Changes. That length changes to some other value. that length will be changes. Yes or no? So that means R value changes as the elementary portion position changes from line of bisector to anywhere upwards and downwards. So R is also variable. So R also we have to modify. So now we are going to write how to modify the dq, how to modify the R, if you understand that one, so that we can go for next derivation of this one. Now come to the case of next. So this elementary portion, due to this there is electric field. This electric field, whatever we taken here, that is also small electric field. You can take it as, you take it as dE electric field. Okay. So for understanding, we discuss normally. Now you can go for exact expression of this one. So the electric field is due to, that one is equal to what I can write, that is nothing but dE I can write. So dE. So this dE, if you resolve into components, you are going to get dEx component. This is nothing but called as dEx, and another component we can write as, that is dEy. So what is dEx? dEx equal to nothing but dE into cos theta. What is dE? So dE is equal to 1 by 4 pi epsilon naught, just before we done, that is d cube by r square into cos theta. So if you observe this one, what are the variables here? dq is variable, r is variable, theta is also variable, because as you are changing the elementary portion position from, okay, from here to here, anywhere different positions at, okay, below the line of bisector, above the line of bisector, what happens, theta value is going to be changes, so cos theta value also changes. So these are the variables. So I can now apply the integration here both the sides. This integration, while you are applying, what is the limits you have to take here? First, if you observe this elementary portion, I can choose it in the below also. I can choose the elementary portion below also. If you choose the elementary portion below, now this elementary portion makes an angle here also theta. So if I say here, this is theta 1, if you say this is theta 2, I can write. Okay, so in this case, I can write the limits here minus theta 2 from the, okay, line of bisector, it is below, so negative axis, line of bisector above, positive taken, minus theta 2 to plus theta 1, you have to integrate. So in this case, before that, what I said, first integral dx equal to take it as ex, and keep the constant outside, because constant not having integrations, 1 by 4% not, okay, is a constant. Now remaining is integral minus theta 2 to plus theta 1, and that is d cube by r square into cos theta. Now our part of understanding is what is dq, what is r, that conversions we need to understand. So look at the diagram here. In the diagram, first you need to understand the concept of dq. So what is dq? Charge. Total charge of the wire is q, total length of the wire is l. The charges are distributed linearly, so there is a linear charge density, lambda. So lambda is equal to, we can write as charge occupied per unit length. So from this I can write q is equal to lambda into m. So this is also previously learned. Now in the case of elementary portion, that means what are the small portion you chosen? Elementary portion, this elementary portion, okay, dl, length elementary portion, dq is equal to lambda into dl, I can write. Lambda into dl. Now this dl also we can write in the form of some theta also we can write. What is I can write? dl is equal to, if you want to write in terms of what way, that we can substitute here, just dl. Now next, what is that? R. What is R? Radius. So in the total diagram, what is constant? X is constant, L is variable, R is variable. So here our requirement is the L, we have to change. L is a variable, okay, dq is a variable, lambda is constant, dl is again variable, because you can choose it from different values. So dl also variable means you can write the, okay, length is variable with a constant. So if you observe this triangle, I am writing in red color, this is, you can check it. This is the triangle we have. From this triangle, what I can write? If you see this triangle, from this triangle, L is length, X is distance, X is constant, L is variable. So as length is anyway the variable we got to write in the form of fixed distance x. So write the relation. This is theta is the relation if you say. So opposite, it becomes length becomes opposite by adjacent. Opposite by adjacent is nothing but tan theta. So I can write here tan theta is equal to, I can write one of the relation here. Tan theta is equal to what I can write here. Look at this. Tan theta is equal to nothing but opposite L by x. So L is equal to what I can write? X tan theta I can write. L is equal to L by opposite by adjacent is equal to nothing but tan theta. So L is equal to x tan theta. Now what you do is differentiate this one. If you differentiate, it becomes dl. dl is equal to nothing but x is constant, no differentiation. Tan theta differentiation is secant square theta into d theta. This is a formula. So x is constant, secant square theta is variable theta. That variable theta we can differentiate in terms of limits minus theta 2 to theta 1. So now apply this condition in the above equation. So Ex equal to, I can write as 1 by 4 pi epsilon naught, that is integral minus theta 2 to plus theta 1. If you apply here, what is dq? That is nothing but lambda into dl value is equal to x secant square theta into d theta by, okay, r. What is r value? R is nothing but distance. R is also not given. So write the r value. Which is r? This is r. This is r, this is x. Write in the form of that. So from the triangle, again same triangle, this becomes adjacent by hypotenuse. Adjacent by hypotenuse nothing but what you are going to get. Adjacent by hypotenuse, that is r by, sorry, adjacent by hypotenuse means x by r you are going to get. X by r is equal to cos theta. So from this r is equal to nothing but x by cos theta. That means r is equal to x secant theta you are going to get. Okay, x secant theta. So in this case, 1 by cos theta equal to secant theta, we can write x by secant theta. So if you differentiate this one, what you are going to get? Just a minute. In the formula, what is required? R is equal to x secant theta we got now. Our formula is r square now. What is r square value? X square secant square theta is the formula. Now if you observe this one, here I can cancel some things. What is that? Secant square theta I can cancel. Here we have x above and below also we have, okay, x square is there, 1 x I can cancel. So in this case, our requirement is, okay, to calculate lambda by, okay, just we have what is the equation we got? That is Ex equal to nothing but 1 by 4 pi epsilon naught I am taking as k into, that is integral minus theta 2 to plus theta 1 into lambda is constant I am taking outside and remaining is d theta, just we have. Remaining all are cancelled already. So k lambda into d theta we got. So now we have to differentiate this one, d theta. Now in the every equation we have one more term is there. What is the term? Cos theta. So here also we have to take one more term, that is nothing but cos theta we have term here, cos theta. So if you take in here, that becomes, if you write in order, I can write this one as cos theta into d theta. So this is one of the expression we need to understand how we got this one. Using this you can calculate the Ex value at that point. Now integrate this one. If you are integrating, Ex equal to, what is you are going to get? K lambda into integral cos theta d theta is equal to nothing but sin theta you are going to get. The lower limit of this one is minus theta 2, upper limit is theta 1. If you apply that condition, that is k lambda into, I can write in the bracket sin theta 1, minus of minus becomes plus, that is sin theta 2 you are going to get. So this is one of the expression you got. So what is lambda here? Lambda is equal to nothing but we can write as charge occupied per unit length. So I write in the full form of this one. What is k? K is nothing but 1 by 4 pi epsilon naught. What is lambda? Lambda is nothing but in terms of charge occupied per unit length we can write, that is q by L we can write into sin theta 1 plus sin theta 2. This is the formula we are using to find the electric field intensity due to charged wire along x-axis. Now in the case of vertical component electric field, that is to calculate the DEY. So what is DEY? You can see that already. DE is the electric field intensity due to this elementary portion above, downward direction. If you choose the elementary portion below here, then the electric field will be upward. So I am taking DE is equal to DE sine theta. This component varies from minus theta 2 to plus theta 1. Up to this it varies. So DE is equal to nothing but, that is DE sine theta is the our required integration to get the electric field along y-axis. Now we are going to solve in the same like similar to this one. If you compare this one in the same like, electric field along y-axis is equal to, we are going to get k lambda into integral minus theta 2 to theta 1. In the place of cos theta, we will get sine theta into d theta. Same, remaining everything is same. Now if you differentiate that one, what you are going to get the relation here. If you differentiate that one, the relation you are going to get Ey is equal to nothing but, so k lambda into integral sine theta is minus cos theta, that is minus cos theta, lower limit is minus theta 2 to upper limit is plus theta 1. If you apply that condition, I can write the equation expression of that one as Ey is equal to nothing but, k is nothing but called as 1 by 4 pi epsilon naught, lambda is nothing but charge per unit length into, this is nothing but, if you taken here minus cos theta 1 plus cos theta, that means I convert as cos theta 2 minus cos theta 1 I convert. So in the case of infinite wire of length, so what is the expression? This is the expression for, okay, at any angle, that means elementary portion I chosen at minus theta 2 to plus theta 1, but our requirement is for infinite length. Infinite length means this elementary portion which you chosen, that has to be at infinite. So we are going to apply that condition for next. These two formulas you have to keep in mind. Now already we got the Ex value, Ey value in terms of theta. Now apply this condition to the any type of charged length of wire. Now in the case of our discussion, infinite length of wire, if you apply here, what is length of this one? Infinite. Now if you choose an elementary portion at infinity, how much angle it makes with the conductor? That means before, if you choose the elementary portion here, it is making an angle some theta. If that elementary portion, if you shift it to infinite, so how much angle it makes? That angle made by this one will become how much? If you take an infinite means, that angle will become theta is equal to 90 degrees, that is pi by 2 it becomes. So here also, if you choose the elementary portion here, it makes some angle that is theta 2 like we can write. But if you taken that elementary portion at infinity, here also the theta value will become equal to pi by. Apply this condition, the above equation, what you are going to get. So that means for the, in the case of infinite length conductor, theta 1 is equal to theta 2 is equal to 90 degrees, pi by 2 you have to choose. If you apply that condition here, what you are going to get, Ex equal to, that is q by 4 pi epsilon naught into L into sine 90. What is sine 90 value? That is nothing but, this is sine pi by 2 plus sine pi by 2. Sine 90 value is equal to 1. You know that. That means we can write as Ex equal to q by 4 pi epsilon naught into L. That is nothing but, you are going to get 2. Sine pi by 2, 90, sine 90 is 1. 1 plus 1 is 2, that is 2. So 2 we can cancel 2 times. So electric field intensity due to this charge wire, infinite length along, okay, x-axis is equal to what I can write, that is q by 2 pi epsilon naught L is the answer for question. This is the answer. Okay. Q by 2 pi epsilon naught into L. Now in the case of y-axis, if you come across it in the case of y-axis, theta 1 is equal to theta 2 is equal to 90 degrees. If you substitute that, cos 90 how much? Sin 90 is 1, cos 90 is 0. This is 0 minus 0. Ey value will become equal to how much? That is q by 4 pi epsilon naught into L. This value 0 minus 0 will become equal to 0. So electric field along y-axis is equal to becomes 0. So now what is electric field intensity due to complete charge of infinite length wire? That is sum of the x component plus y component. In this case, y component is become 0. So electric field, net electric field due to the charge wire is equal to only x component. That x component value is equal to how much? Q by, that is 2 pi epsilon naught L we can write. Also we can write as lambda by Q by L is called lambda, that is lambda by 2 pi epsilon naught we can write. This is the way you can able to express the answer for your question. Here starting onwards we left we forgot one of the variable here. If you see the previous pages, so in this, which is the this one, here we cancel the above x below x square, that means one x left here. So every case we have a x will be there present in the every equation. So in the first page we have a x is there, in the second page also every term contains x in the denominator. So this also contains x, everywhere we have x. So that x also we have taken into consideration in every part of derivation. X is the distance of that one, so x will be present in every equation. So if you write that, if you take on that x value, so what is the last equation you are going to get? That last equation, if you choose in that x value in the every expression of that one, so we have x also present here. We forgot that x, you check it that one, so that is only you need to check it. So x, so answer is E net is equal to nothing but how much you are going to get, that is lambda by 2 pi epsilon naught into x here. This is expression for electrical intensity due to infinite length charged wire.